Okay, welcome all. I'm Santtu from the Qt company, and I'll be your host today here in the university substream. And our first afternoon presentation after lunch is Trim, talking about the Thermomix project and practical insights into scalable Qt development. So, Trim, please go ahead.
Thank you, Santtu. First of all, I'm surprised that so many people are here. And then Nikos is giving a talk about the Qt 3, and I thought that nobody will come here. But thank you. I hope that you will also leave from here satisfied. Let's go. My name is Przemysław Nogai. I'm head of the HMI technology at Spyrosoft. And actually, I'm a QML developer, mainly QML developer. That's how I think about myself. And today, thanks to the courtesy of the Vorwerk company, I will be talking about how we engineered, or how the engineering process of the Thermomix TM7 HMI looks like. So I will try to share some practical insights, maybe something new for you. I hope that you will find some ideas for your own projects, right? So I won't have as many nice food images like the Stefan had yesterday. So this is actually probably the most beautiful photo in my presentation. But I'm also in the better position because I'm after lunch, not before. So that's always better, because we will be talking a lot about the cooking, right? How to cook the applications and scalable applications. So maybe a rhetorical question. How do you think, how many people were working on this Thermomix? Anyone? Some guesses? What? Yeah, 3.5. No, kidding. Myself, I don't know. Each day in this project, I'm meeting some new people that are bringing the impact here, right? So yesterday, Stefan was telling us we have a vertical teams, right? So the teams that specialize in some areas of these cooking activities. So I brought, could you steer something, Santtu? Better, I think. But thank you. Sorry about this. No worries. So I brought some of the teams, just not all the teams that were involved. Those are teams that I usually work closely in these projects. And those teams are built from both Vorwerk internals. So we have today great developers like Nora and Katarina. There are some guys from Qt Professional Services like Dominic. There were guys from the Silly, from KDAP, like I said, from Vorwerk internals, and also 30 Spyrosofters like me. So you can see we have some system team, base framework team, app framework team, build team, my favorite one, and I hope that the guys are watching that or the recording. So Paulo, Sebastian, Mara, everyone else, thank you for your work. We have some PAPs team, recipes team, total quality team, really important one, modes team, core apps, and global UX, right? Each of those teams on the daily basis was actually in kind of discovery and delivery mode at the same time, right? So sometimes they made 2 steps forward just to discover that what was great design doesn't work for the users, right? So they need to take 2 steps back, but all of those teams are delivering a content for a customer, right? This product is customer driven. This is a product for customers, not for fun, not for engineers. This is something that 5 million users are using on daily basis, right? So we had to make sure that they will be satisfied. And basically, let me just take you through some user journey. All right. So when user starts the Thermomix, what's happened? You might see the start screen. So you can see how many teams already brought the content to that screen, right? And without those teams, the screen wouldn't exist, right? Then the user might want to enable the Wi-Fi. So we have new team, core apps, that actually developed this application for configuring the Wi-Fi, right? So let's move forward. Once we connected, maybe we would like to search, to cook something, right? Because that's the device shall do. We have a search team. They specialize in searching the recipes. They have all the knowledge. We have a recipe team that knows how to present the recipe, what's important, how to build the recipe. but also was responsible for building that screen. And finally, we would like to cook it. So we have, once again, the color apps team, but also the mouse team. So you can see how many teams contributed to each of those screens, right? And now that's a challenge. We had a limited time frame. We cannot wait for each other. We need to develop in parallel. How to achieve that, right? So that was actually the question we started with. And I like the one term that Julius Gans, the Chief Digital Officer of Vorwerk, used. We need to behave like a team of teams, right? Everyone is kind of independent, but at the end, we are delivering a single product, right? It needs to all fit together. So of course, to achieve that, you need to put some common goal for the teams so they understand what we are aiming for. You need to have a great quality assurance. That's why in each of those screens, we have this TQ team. You need to have a great integration methods, right? So that's why we had a build team there. And things I will focus on this presentation is about you need a great architecture that supports that, and you need some UX consistency. So let me start with architecture. So more or less, this is where we started, right? So we knew that this device connects to the cloud. I won't talk about the cloud too much today, that it has some hardware, of course. It has some OS drivers, third-party system services. It has some system services, so that's why the system team was there. It has some middleware services. That's why the base framework team was there. And what's probably most interesting for all of you is that we need to build a presentation layer, right? The HMI, something that faces the user. So we started with knowing that, yeah, it will be cute, of course, but cute what? How we can support all those teams, many teams, delivering the content at the same time and not killing each other, not waiting for each other, being efficient. So this is where the Qt Application Manager enters the scene. I don't know how many of you use the Qt Application Manager or heard about that. Yeah, Dominic heard because he's maintainer. Santu heard also because he works for Qt, but not so many, right? This is a little known module or tool. I don't know how to call that. But basically what it does, it allows you to separate some global UX behaviors and composition from individual apps, right? So domain-specific content. So it has a built-in Wayland compositor. It allows you or delivers you the concept of application packaging and handling of that, like installation, uninstallation, update. And it allows you to also control the lifetime of the application. To start it, to stop it. Yeah, that's it. It helps you to manage the user input, like embedding the virtual keyboard. It provides you the mechanism of notifications, like on your mobile phone, right? So each of the applications can notify about something. Sorry. Yes. All right, so notifications. It also has a concept you might know from the Android development, like the intents. So that's another brick in our architecture, right? So we know it's not only Qt, but also Qt Application Manager. All right, so I've told you that it allows you to separate some global UX from domain-specific UX and user interactions. So let's once again take a look on our home screen. So basically what you see as the blue area is the home screen application, right? This is a window. We have some widget from MyWeek application, right? Keep in mind that each of those teams had a separate UX. They know how to present that information, right? So they have area, how they will use it, it's up to them. And we have some system UI elements that allow you to switch between the apps, to open some cooking center and so on. So this is a really boring slide, but it shows you that, yeah, on the left side, we have system UI, which is QML only application. There is barely nothing in the C++ there, right? So we have some app windows composition layer, some dialogues composition layer, some widgets loading layer, and each of the applications, I've gave just 3 example ones, can expose a different set of those windows or widgets. All right. Right. So what is the application? Application actually consists at minimum of 2 things, right? So one is the application manifest. This is a YAML file that points you to the main QML file. So the other required element is the QML file. And basically, you have the application. So this is actually an example of the application. You can see that normally it shall derive from some, for example, from some application manager window. But we started to build up wrappers, right, to help to say that, yeah, this is a kind of a, application manager window that lands on the dialogues layer, right? This is a kind of application manager window that lands on the main area, and so on and so forth. So that's how we started to fill the rest, right? So we have, I don't know, 40 plus applications already. We have some system UI. Those are just QML code components, right? We have started to shape our Vorwerk app framework, which is having some app windows wrappers, some widget templates wrappers for now. Let's see what we need more. Okay, actually it's not internet, it's intent. So I've told you a few minutes ago that Qt Application Manager also provides the intent mechanism, right? So let's consider the guided cooking application and manual mode application. And guided cooking would like to start the manual mode application, but it shouldn't know that the manual modes application exists at all, right? It should just have some abstract interface. And this is exactly the intent. So the intent consists of some ID. And in this case, this is this conf_vorwerk intent dot something, and some arbitrary parameters you can set with that. So returning to the manifest, in the manifest you have a section where you can define the intent IDs. There's no place to actually define the parameters there, right? So, but basically to make sure that it's kind of abstract communication, you have to provide kind of documentation, right? So the guided cooking application developers know which parameters to supply if they would like to start this other app. They don't know what kind of app is that. It might change over the time that the other app will take that responsibility, but the API stays the same. So we need a documentation for that, right? To describe what kind of parameters. Yeah, right. So now we have app framework with some app windows, widget templates. We have system UI, we have 40 plus apps. And now those apps can talk to each other. Although they don't know who is on the other side. They just can send some request to system. I would like to start something that controls cooking. I would like to start something that shows the recipe to the user, right? They could send something to the system UI. Yeah, we have some abstract interface which we can use for testing, right? So just think about the intents, incoming and outgoing, as the interface of the application, right? So it's a perfect for testing. We can test that in the separation. Yeah. Okay, and now it would be nice if our applications, our system UI, could also talk to the lower level layers, right? So this is where Vorwerk came in with idea of the SHLAPI, which is this acronym for the Semantic High-Level API. So basic, the SHLAPI is just the IDL file, right? It describes some functions like actions, events, properties. We have some tool to process that and to generate 2 things out of that. So simulation plugins and C++ plugins that directly using Vorwerk IPC framework can talk to the lower system layers. And I won't focus too much at all today on the simulation plugins. But I will show you some things about the C++ plugins, right? Because I believe that's something really interesting. Okay, so this is a piece of QML code where actually we are using the SHLAPI interface. This recipe catalog is recipe available. It's an action that we can invoke on our SHLAPI. The problem is that this action is asynchronous, right? So in the past, usually what as the QML developer I was doing, from the C++ part, I was exposing something that, yeah, the action succeeded or the action failed, right? I had some properties that were talking, this is the action result, or this is the error associated, right? But actually, as QML or Qt Quick in general implements also the ECMAScript, we can use the JavaScript promises. This is a really little known fact that QML supports the promises. It allows you to actually call this method. And whenever it will succeed, so then we could do something with the result. If it fails, we can catch the error, right? So this is a pretty useful mechanism in case of the asynchronous operations. So we don't need to block, we don't need to wait, we don't need to observe for multiple signals. We can just have that. What's more, if I will return another promise from my code, then I can do another chain of the dance, right? So I can build the well-structured code, something that I would like to see also in the C++. Unfortunately, those proposals got lost. So async doesn't mean that it will take forever, right? So async might be immediate or might happen in the 5 seconds from now. Well, the coroutines, but they don't have the nice syntax like this one, right? There was a proposal from the Herbstatter to have exactly this kind of syntax. There was implementation from Microsoft to have this syntax, but it's not part of the standard, right?
But then you said you call it.
Yeah, of course. Yeah, but I would love to see exactly this syntax, right? Because it's clear to read, it's clear to understand.
I think the problem.
Cool. Let's talk about that after, because otherwise I won't fit into the time. So how the recipe catalog is implemented, right? So this is actually generated code. So none of the developers see that code, right? So we are taking the IDL, we are having some internal IPC mechanisms there just to call that and return the result, right? So you can see that this is the method I was showing on the previous slide. And on the QML side, this is a C++ counterpart. And this method is returning the JS value. So JS object, actually it will return a pending reply object casted to the JS value. I'll show you how the pending reply is working. So in case if the, I will just focus on the successful case. Success stories are always the best. So in case if the status from the IPC was okay, I don't know when it happened, right? Maybe immediately, maybe after 5 seconds. I'm using this reply object that I'm returning to the QML. I'm returning that directly below those lambdas. So it's an immediate return. I'm setting the reply, yeah. This is a reply. The object that will hold the result is available, will have some field is available set to some Boolean value. What's more, those objects are casted to the value types, right? On the QML side, I can cast them to the value types. So I have QGadgets corresponding to those. So how the pending reply, set reply looks like. So I'm passing some arguments I got from previous call or from the IPC framework. I'm converting them to JS object. And I'm calling some magical onFulfill callback, which is a JS function, or QJS object of the JS function type, with the result. Yeah. This is small. So basically what happens here is that this pending reply actually is using the evaluation of the JavaScript code to create the promise object. Unfortunately, creating the promise object from the for engine is not so straightforward. It's doable, but it would be more complicated. So I'm just creating a new promise. I'm assigning some callbacks. Those callbacks are actually assigned to myself. So basically, whenever the onFulfill or onFail will be called, it's called on this object that I've returned to QML already, right? So QML already has it, and some developer can listen to the results, can ignore the results. Of course, there are a few tricky parts. You need to keep in mind the lifetime of those objects, manage that, but it's not so hard to sort out. All right. So now our app framework provides for the developers also the possibility to talk to lower layers, right? So now they can start writing a functional QML. Keep in mind that we also have some simulations. So if the middleware is not ready yet, they can start using the simulation just to concept something or test something, right? So we have it. And we can see that there is some gap there left because we are missing still some points. I've told you that the enabler for all of those teams to work independently, but still bringing the value to all others, is the UX consistency. And in Vorwerk, it was done in the way that it follows the molecular design. If you're not familiar with it, this is a really cool concept. When you start with some small design tokens, you could think about that like protons and neutrons. Those can be, I don't know, radius, font size, font type, color, and so on, right? So really small bricks. You build some atoms out of that. So atom could be compared to, I don't know, button. You build some molecules. So maybe you have some text input, which is one item, and you have some reveal password button, which is another, but those build molecule. You could build some organisms out of that. You could build some templates that we could reuse to actually introduce a new similar entities. And you have some pages, which are actually the thing that the developers need to implement. And this is invented by the UX that is assigned to their team. So I will just focus on the design tokens and how we approach that. So what is design token, right? So like I said, the design tokens is just this is actually a screenshot from the Figma. So this is actually kind of sets of some basic values like what's the color of the background, right? What's the font that shall be used in such illustration button? So basically that's what the designer configures. Out of that, we have the JSON file. If we have a JSON file, we can create another generator that will generate some code for us, right? So whenever they will decide that this button won't be whitish but greenish, just regenerate the code, right? We will get new JSON file. So for the QML, so we can then use on different states of the such button, which will be atom. We could use a different sets of tokens that we simply got generated, right? So that's a super cool feature, I guess. So we can see that we filled the rest of the gaps. So we have app windows, widget templates, design tokens, common controls, app templates, and SHLAPI plugins for communication. And that allows the developers to actually build separately while still contributing to a common product, right? So yesterday, during the Chris keynotes, he also said that you need to have this personal aspect of every assignment, of every task, right? So I've named it common goal. So let me explain what it means for Vorwerk, right? Here you are seeing the history of the Thermomix. starting from the 1971 to 2025, this 50 years of history, right? I think like 3 generations or maybe 4 generations of developers, hardware engineers that were working on that. 3 or 4 generations of customers. So this is one of the goals, right? This is a heritage that we need to follow. But to make it even more personal, every of us working in this project is doing that for the customer satisfaction, right? So I would like to show you a very special customer. This is my #1 customer, right? So this is my son. He's doing the cooking on the Thermomix. He's doing some cake. Enjoying the work I was doing, the others were doing. Maybe he will be some Michelin star cook in the future. Or at least maybe he will be able to do the dinner for someone special in the future, right? So I don't know. This is the future. And seems that the future is written with Qt. So thank you very much.